All right, folks, welcome back. This is help with number 6. The question presented to us: which of the following procedures would most effectively determine the volume of air spaces in a sample of soil in a container? Presented options A through D. Once again, we are going to just generally apply test taking strategies, see if we can eliminate any wrong answers, which increases the likelihood that we get our answer correct. I'm going to start with option D. Let's see if we can find some low-hanging fruit. D says calculating the volume of a soil sample when it's spread out over a thin layer. Well, whether that sample is concentrated in a column that goes straight down 6 feet or spread out, that doesn't really help us anything, because we know that based off of the original question, there's still going to be air pockets in that soil. Whether we change the shape of the soil, that does not really help us determine how much air is in that, so D is not a good choice. Let's just go up the board. Looking at option C, C says comparing the volume of soil with a volume of a rock of equal masses. Well, same thing. You can take a soil and you can redistribute its shape or its contents. You can take a rock and break it down and have equal mass, but that still does not tell you anything about the air pockets that are going to be inside of the rock. So this definitely is not a good answer either. Let's go up to option A. Option A says observe the change in volume as it's compacted by a large, heavy object. So I took some paraphrasing there. That would be a way to determine how much air is in the original soil if you found the difference of the two before and after. However, if we compare that with option B, says measuring the volume of water needed to simply saturate the soil sample. Between A and B, B is the much better answer. This is simply using the concept of displacement. You could effectively get an answer if you work carefully with A, but B would be the much more straightforward way to get this. You could take a beaker that has graduations. You know how much water is in there. You pour it out. You measure how much is there at the end. That tells you the difference. So B is the most straightforward, effective way to determine the sample of air spaces in a soil solution. That was number 6.